Hello, everyone, and welcome to our webinar, How to Build a Multi-Agent AI App with AutoGen. My name is Matt Brown, and I'll be your moderator today. One of my main jobs at SingleStore is to organize these weekly AI webinars, 2 per week, demoing data and AI use cases and new technologies and tools. I post about these upcoming webinars every week, so if these topics are interesting to you, feel free to connect with me on LinkedIn to stay in the loop. I'd also love to hear your feedback or any ideas on topics that you'd like to see in future sessions. Speaking of future sessions, if you click to the next slide, you'll see that on Monday, we are going to be presenting Building with Google's new open Gemma models. You can come and join to see a live demo and a code share on how to use the new Gemma models. They've got very lightweight designs, open access for AI applications. So if this topic sounds interesting to you, go ahead and RSVP. It's the short link you see on your screen, the Google Gemma webinar. I'll put that link in the chat in a minute as well, or you can just take a photo or a screenshot of that QR code that's on your screen, and that'll take you to the same place to RSVP and get your Zoom link. Hope to see you there on Monday. Back to today's topic. We'd love for you to participate in the Q&A throughout the session. There is a button at the bottom of your Zoom that says Q&A. Feel free to click that, type in your question. We will try to get to your questions as they come in. We'll also have a live Q&A session with our panelists talking at the end of this session, but we'll also try to answer them as they come in. This has gotten tough with so many registrants these days, but we have a mission statement to answer 100% of the questions that come in. So feel free to ask away. Make sure that you include your name and email address in your question, because we will not be answering any anonymous questions. We'd also love for you to try out the technology that we're talking through today. In fact, anyone who tries it today will be entered for a chance to win new AirPods Pros. All you need to do to participate in that raffle is visit that link that's on your screen. It's the multi-agent AutoGen raffle. The QR code will take you to the same place. I'll put that link in the chat in just a minute. And all you need to do is log in. You may know already that SingleStore has had a free trial for many years, but just in the past few weeks, we've also announced a new completely free shared tier. We can talk about that more a little bit later today. So let me introduce our speaker for today. Alex Peng is a growth engineer at SingleStore. His formal training was from the Stanford Computer Science program. He has expertise in big data, machine learning, and AI. He's becoming a regular speaker at these weekly webinars on data and AI. Welcome, Alex. The floor is now yours.
Thanks, Matt. Well, like Matt mentioned, this set of weekly webinars is something that we've been doing because we're really excited about some of these new capabilities that are becoming possible because of this wave of AI. And to really understand and to set a foundation for, the topic that we're going to be covering today, which is, AutoGen for multi-agent AI workflows, we really have to set and understand the emerging architecture that we're seeing for LLM applications. So really the core of this is going to be this whole concept of retrieval augmented generation, which if you've attended our webinars in the past, then you're going to be well familiar with this. But if you haven't, then this would be some good first material to get familiar with. And that's really the idea that when we use these LLMs, on first pass, we use something like ChatGPT, or we use something like, Claude from Anthropic, and we're kind of wowed by like how much they seem to know. They're almost like this, genie in a bottle who can give us all of our answers, right? But very quickly you find out that these LLMs are actually not all-knowing oracles, and instead they tend to do this thing that we call hallucinating, which lots of humans do too, but we especially don't want to see it in an AI application, especially if we're deploying it in an enterprise setting. And hallucinations are essentially when an LLM doesn't have the information necessary to produce an answer, so it just makes things up, right? And to fix this, we've come up with this whole concept of retrieval augmented generation, or The AI community at large has come up with this concept of retrieval augmented generation, and that's essentially taking the semantic meaning of a user's query. So, if you're asking, hey, what are the 10 most profitable companies in my stock portfolio, right? It's taking the semantic meaning of that, and then it's looking across your database for the most relevant information, and then supplementing that information to the LLM so that it's able to give you a more accurate picture and give you hopefully a non-hallucinated answer. And so where does retrieval augmented generation fit inside our kind of wider AI architecture? Well, obviously we have our UI, which is going to be the ChatGPT web UI. It's going to look like some of these AI startup tools that are coming out, like Flowwise, which lets you create a no-code UI on top of any LLM model. We have a great webinar on Flowwise as well. Highly recommend checking that out, also by me. And then one layer below that, we also have the API endpoints, and that's how we're going to hook up the UI and the browser components to our actual LLM. But we don't want an LLM that's going to be hallucinating all over the place. So we also need to provide it with contextual data. We need to augment its generations with retrieval. And that's where something like SingleStore is going to come in, where we're going to perform semantic search. So that's looking at the meaning of your query and then looking for pieces of information that are closest to your query in meaning, and also traditional lexical or keyword search, which is going to be search that looks something like what you do when you go to Google and you search for something. That's going to be much more keyword based and matching along keywords, right? You're going to want to do usually a combination of both to get the best kind of mix of information for your use cases. And just kind of zooming in a bit more into what this contextual data layer looks like. This is obviously going to look different depending on your contextual data store. At SingleStore, we think that our solution is going to be something that's going to be perfect for enterprise use cases, because we end up unifying these two often siloed sources of data, structured and unstructured data, into one single store. And so you can see here, obviously we have, tabular data, from a relational database, in a SQL database, and then also unstructured data, Slack messages or PDFs or CSVs or, Jira tickets, right? All of that information can flow into the same data platform, which we call SingleStore. And then out of it, you can pull semantic and lexical information to augment your LLMs. And what are some benefits of having everything in one, under one roof, right? We think that there's huge benefits to be had, enforcing a single data access policy over the entirety of your corpus of data, right? You don't want to muck about configuring multiple databases, potentially seeing multiple databases fail and having multiple points of failure, when you could just simplify and have one single data platform for all of your AI data needs. So let's think a little bit more about this whole kind of multi-agent architecture that we've been seeing recently, and hopefully the reason why everyone is here today. I want us to think about the typical, LLC, the typical company, right? At the top, you might have the CEO, and then you might have directors, then you might have vice presidents, and then, under vice presidents, you might have some managers, and then under the managers, you might have, engineers or customer support agents, or, salespeople, the list can go on. But really, we see this hierarchical structure, right? And why have this hierarchical structure? Because the organization as a whole is usually tackling a problem which is much, much larger than any single person can take on, right? And so, some very smart people got together and they thought about this when also the whole wave of LLMs is coming out, and they thought, well, hey, we're throwing some pretty difficult problems at these LLMs, and oftentimes they're not doing as well as we hope for them to, right? We're asking the LLM to, hey, go into like my library of like 3,000 PDFs and answer this really complex question, or go over my entire email inbox and draft answers to every single unread email, right? We wouldn't really expect, a person with no context, no insight into our lives, to just be able to handle these tasks by themselves, right? So why would we expect that, why would we expect that a single LLM is able to do this? And that's where these multi-agent workflows come in. We've seen today we're going to be focusing on Microsoft's AutoGen Studio, but we've also seen actually just very recently, LangChain came out with a really great multi-agent framework called LangGraph, and that's actually that's also really cool because we're directly integrated into LangChain. And so if you'd like to work with LangGraph, and you're not especially tied to AutoGen Studio, that's another great alternative that I'd suggest checking out. But really, the meat and bones of what we're going to be talking about today is taking this concept of, a supervisor LLM, deploying sub-agent LLMs, and then really putting it to practice. And what does this look like? Well, going back to the previous example of, drafting responses to an entire inbox of messages, right? Like you might think, well, I mean, why not just feed it to an LLM in sequence, all of these unread emails, and then it'll just give you, it'll give you a perfectly good enough response, right? But I think it's taking the naive approach, as we've seen in AI, often gives, very quick results, but not necessarily production grade and enterprise grade results, right? You're going to run into problems with hallucination. You're going to run into problems with, benchmarking. You're going to want to make sure responses are up to a certain amount of quality, right? And that requires that, for example, again, going back to this email example, that, potentially we send out a supervisor LLM for each email, right? For each unread email. And we have the supervisor LLM, send out an agent to get context from other email threads. And then we send out an agent to get context from, the most recent items that you've been working on, like the most recent, like Google Sheet, or the most recent Google slide you've been working on. Maybe another agent goes into, your Slack and pulls up your Slack history with all of the, with everyone in the thread, right? And then these agents will summarize what they found and then bubble that back up to the supervisor LLM, who then takes all of this information, right? This additional context, right? And produces a much, much better response than, the most generic possible first pass an LLM would get you. So just to recap a little bit, some considerations for multi-agent workflows. Obviously, we want to think about the complexity of the task. If we're just generating, a poem for our very good friend, and we want to give them, we want a little poem for their birthday card, then maybe a multi-agent workflow is overkill, right? But again, if we're going into these more complex tasks, like, working over a giant data set, or working over or performing a task that requires multiple steps, that requires maybe even multiple long-ranging steps that are separated in time, right? And so maybe we need to schedule agents. These all start to give us clues that maybe we need a multi-agent workflow. Second, is the complexity of the task recursive? And this is an interesting kind of point to think about, right? If your task is, to respond or provide a first draft to all of your unread emails in your inbox, right? You can think of the performance of the task almost as the quality of the first draft for each unread email in your inbox, right? And if you can break down your task into the kind of those sub pieces, right, and measure performance in your task by the performance in each kind of sub piece, then you're starting to get to a problem that might be well suited for a multi-agent workflow, right? And then third, let's think about how easily chunked is the task, right? Oftentimes, you're not going to find that a really difficult problem is so easily divided into nice little discretized units. Take for example, you're doing a complex question answering task over 3,000 PDFs. That's not a super easily that's not a super easily chunked task, right? You might think, oh, well, I'll just chunk by each PDF, right? But maybe you need to pay special attention to certain PDFs and you could ignore entirely other PDFs. Well, that, introduces some additional considerations into the system. And then finally, and this is a concept that we've talked about if you've joined us for past webinars, is how many parameters do we need for sufficient performance? And this is always going to go back to benchmarking, right? If you are deploying these multi-agent workflow, any LLM application really, but especially these multi-agent workflows in enterprise, you better make sure that that you're actually introducing a significant improvement over the baseline, and that you know how to measure that significant improvement over the baseline. And maybe you get to that really significant improvement by using a model like GPT-4, which is, I think, has been last reported like a trillion parameter model, but that's using like a V12. Maybe you're using like a V12 engine for your commute to the grocery store, right? You might not need that many parameters. You could be instead getting maybe 75, 80%, 90% even of that performance on a fine-tuned, 7 billion parameter model, which is, orders of magnitude less and could even run locally. You could get that performance on a much, much lighter model. And actually, that's something that we're going to be talking about next week at the Google Gemma webinar. That's a new family of low parameter count models, which has demonstrated really astounding performance. And then, final point of consideration is, well, something interesting that we've seen possible with these multi-agent workflows that you can't really do with just a single LLM is that you can actually vary the amount of the parameter count of the supervisor LLMs versus the sub agents, right? Traditionally, you're not able to do this. You kind of have to make the decision for how many parameters you'd want, or basically the model you'd like to run before you actually run it. But some people have found really good success in a GPT-4 supervisor LLM, which is really, really skilled at coordinating some sub agents, right? And then the sub agents are like 7 billion parameter LLMs that are super specialized in a specific task. Maybe don't have general performance across a number of different tasks, but it doesn't matter because the supervisor LLM is going to know exactly the tasks that they're good at, send them out to do it, and then the sub agent is able to run much more cheaply than a GPT-4 agent overseeing other GPT-4 agents. Okay, great. So we're going to get into the live demo really soon here, but I just wanted to talk a bit more about SingleStore. And so SingleStore is a database. We call it a database to transact, analyze, and contextualize data in real time. So we run on-prem, we run in the cloud, and in hybrid environments. We have row-based storage, in-memory storage, We're horizontally scalable, infinitely scalable. We've also included a bunch more kind of data modalities over the last few years. We've actually had vectors since I believe 2017. And so we've been in this space for a while. It's not a fad for us. We have columnar data, obviously vector data, which is what we're interested in today. And most recently, we've introduced notebooks, which are which we'll hopefully get to show the demo in today. But it's just a really cool way to run Python notebooks or Jupyter notebooks inside of SingleStore and right next to your data, and able to talk directly to your database. Just some really quick statistics on SingleStore as an organization. We've supported over 3,500 users at Uber. We've had an average of 10 millisecond response time, 10 million upserts per second, analyzed over 1.2 million smart meters. I won't bore anyone with too much of the details here, but just some quick stats. All right. Let's take a look at our demo for today. Let me just double check. We have been having some technical difficulties, so I'm just going to double check that it's all set to go.
I think you're good to go, Alex.
Good to go. Okay, great. Let me see if I can go ahead and start sharing it. All right, fantastic. So let's see. Matt, are you able to see my screen all right?
Yeah, I can. You could maybe click the plus.
Okay, let's do that.
Or twice. Yeah, that's looking better. There you go.
Great. Okay. All right. Okay. So now we're going to jump into a notebook, kind of looking at how to actually put some of these concepts that we've talked about in practice. So really quickly, obviously, we're going to need to install some of these packages that we've seen come out in the community a lot. LangChain, we're going to be using the LangChain integration with SingleStore today. We're also going to be using AutoGen Studio, Microsoft's AutoGen Studio. And then we're going to be supplementing our AutoGen agents with some additional information about actually a Microsoft library called Flamel, right? And the details of it aren't super important. What's important to remember here is that we're going to be deploying an agent to essentially go look over our, or we're going to be emulating a software team, right? Which is going to deploy a software engineer, a product manager, and a retrieval agent to basically come up with a response to a user question, right? So you might be thinking, oh, that's kind of interesting, right? Because usually when you're asking an LLM to write some code for you or something like that, you're presumably just asking one LLM. Maybe you're just asking ChatGPT or you're asking GPT-4, and it usually doesn't actually have access to your code base, right? But here we're actually going to define the structure for a software team, and we'll get right into the details of how that's actually all defined. So let's see here. We will be sharing out this notebook with everyone after the webinar, so just stay tuned for that. I believe it's going to be going out to everyone in emails, but yes, you will have access to all of this code. Whoops, I'm going to have to deactivate that OpenAI key. So we're just installing some packages here. And then to start off, we're just going to be defining the retrieval architecture for our retrieval agent, right? And so LangChain, our SingleStore's first-party integration into LangChain makes this super, super easy. What we do here is we essentially read in the markdown file, which is going to provide some documentation about what the context that we're interested in, and we're going to load that into a SingleStore database. And you'll be able to see that actually here. I've already preloaded all of this, but if you run this code for yourself and you run this on your own SingleStore database, you're able to also run this on a SingleStore free shared tier. If you run this yourself, you'll be able to see it populate your own database. But I'll just pull up the database here. This is what the data looks like. Let's see. Oh, it is automatically suspended as of right now. So I will actually, what I'll do is I'll just go ahead and spin it up, and then we'll come back to it at the end. We'll give it a minute to warm up. Let's go back to the notebook here. Awesome. Okay. So essentially what we do when we load in this data into SingleStore is we're going to split up our markdown file or whatever data that we're interested in, really. LangChain is really cool because it supports all these different document loaders. It doesn't just have to be markdown. There's PDF loaders, there's JSON loaders. You can load in web URLs. You can load in a Notion page. If you go look at the LangChain community website and you look at their documentation, you'll see just a really extensive list of all of the document loaders that they have, and you can use any of those with SingleStore, which makes dealing with all of your data really, really easy. But essentially, what we do is we take the data that's been chunked up, right, by our data loader and the text splitter, and we vectorize it with not SingleStore, but we vectorize it with in this case the OpenAI embedding model, which is just going to be text ADA number 2 or something like that. And what's important to understand here is that when we're vectorizing data, we're essentially converting data into a LLM understandable format. And what's more important to actually remember is that you need to use the same embedding function that you vectorize data on ingest with as when you query your data later, right? Because you can think of it as trying to fit, a square peg in a round hole. If you use a different embedding function when you're ingesting the data compared to when you're querying the data, you're going to get really wacky results. And so really important to keep those two the same. It looks like it just spun up, so we can connect it here too. Let's see. We'll give it another second. And so this cell is really what's going to, in one line of code, combine all those concepts that we just talked about. It's going to create an instance of a SingleStore database as a vector store by taking in all of these documents that we have now split up. You can define a custom table name, or you can leave it default. And we're also using the embedding function that we've defined earlier. I'm actually going to really quickly take a look at the Q&A just to make sure I'm not missing anything. So, okay. Looks good for now. Awesome. Okay. We will have time for more Q&A at the end. So here we're just going to be installing the retrieve chat module of AutoGen Studio, the Python SDK of AutoGen Studio. And then here we actually define a custom single store retrieval agent, right? This is a work in progress. I think if we see enough interest in AutoGen, you will definitely offer a first party integration with AutoGen Studio. For now, this is a really great place to get started. But essentially, this is just some custom logic that I wrote that creates an agent in AutoGen Studio, which is able to query and which is able to essentially retrieve documents from your SingleStore vector store, right? The details of it, I'm not going to get too into the weeds of, because hopefully everyone is, more interested in the applications than the actual implementation of like a data integration. But if there's questions about that, I'm happy to dive into this. But at a high level, what it does is it just wraps around the LangChain integration with SingleStore and performs similarity search whenever the agent is requested to retrieve the most relevant context for the conversation that the agent is in. So that's what it does at a high level. But once we've defined that agent, let's see, let's delete this again. We can finally get into actually defining the multi-agent architecture. So, okay, that was a lot to get to the meat and bones. All right, let's see here. All right, and stick with me here. It's going to get a little hectic. So do put any questions you have in the chat. But hopefully this is clear enough at the end. First, before we do anything, we have to define what LLM model or what LLM provider the agents are actually going to use. And here we're just going to be using GPT 3.5 Turbo. Obviously, you can, and this is a across the board configuration that we're going to be using for every agent. But you'll see here, we can actually define an LLM config argument for each agent, right? I'm getting a little ahead of myself here, but the product manager agent, the code reviewer agent, the Python engineer agent, you can see some of these concepts come in of where we could potentially, think about how to tune the number of parameters or really the model that we'd like to use for each agent. Maybe it's really important that we give the Python engineer a GPT-4, model, for example, but actually maybe we only need to give the supervisor agent, GPT 3.5, because it's not a super taxing task to be able to delegate between just 4 members of the team or something like that. You can kind of see some glimmers, hopefully, of where these concepts can hopefully apply to your own use cases, right? But anyway, going back to what we were talking about all the way at the start of the demo, essentially what we have here is a boss agent who is the proxy for the user. It essentially is the agent that relays the user's intent to the rest of the agents. We also have this boss aid agent, which augments the boss's context with information from our SingleStore vector store, right? So in the case that we need extra content to be retrieved, like for example, we'd like to, pull in some code documentation from that was created after the LLM was pre-trained, then we want to use this SingleStore retrieve user proxy agent. And here we also, important to note that we're also going to give it the SingleStore database as an argument, which is different from the normal retrieval user proxy agent, if that's what you're familiar with from AutoGen Studio. Finally, we're going to define just a few other agents who are going to kind of work in tandem and work with all of this information to give us hopefully a really great final output. We have a senior Python engineer agent who has a system message and then a description. So the system message is the message which is appended to the top of this agent's generations, to every single one of this agent's generations. And the description is the description of the agent, which is given to the boss agent, right? Which then is able to understand, hopefully, okay, I need to give this task to the senior Python engineer. I'm going to give this task to the product manager, much like how, you know, in a corporation, we see delegation among, you know, different tiers of the organizational structure. Great. So, so we're going to be showing just really quickly two functions, rag chat and no rag chat, hopefully to show the power of being able to perform retrieval augmented generation versus no retrieval augmented generation. I realize I'm running a bit tight on time here, and I really want to make sure that we get to as many questions as possible. So I'm going to speed through the rest of this just a tiny bit. Let's see, rag chat, no rag chat. And then when we actually call our rag chat, you'll see that we end up retrieving content from our SingleStore proxy agent, user proxy agent, to give additional context to the boss agent, which is the agent that ends up, you know, bubbling up the final response to the user, right? All right, and then finally we have this concept in AutoGen, and this is really the crux of it, of a group chat, right? Just like how you might have a group chat with your friends. Here we define a group chat between, you know, the boss, the product manager, the coder, and the code reviewer. And we also define, you know, the max number of messages that are allowed to be sent between each other. You know, there's a number of different, you know, speaker selection methods that we can define that AutoGen has. But in this case, we use round robin. So we just go around the circle. Everybody goes one at a time. And then now hopefully we can see what this group chat actually looks like. So first we're going to look at the no rag chat. And so to start off, the boss, you know, asks, how do you use Spark for parallel training in Flammel? Give me sample code. And this is, you know, details of this we're not going to dive too deep into, but again, what's important to know is that Flammel is a library which was built by Microsoft, but actually built and defined, or this relevant documentation was defined after GPT 3.5 was pre-trained. And I believe GPT 3.5 was pre-trained last in, like, it was last updated in probably March of 2023. It was released in November 2022, and then they've updated its knowledge up until like around March 2023. Though don't cite me on that. But well before Flammel was actually defined here. And so when we see the Python engineers' response, it's actually totally hallucinated. We see, you know, some, you know, like this is the problem that obviously with hallucinations, and that hopefully everyone has run into already. And so you've seen the kind of motivation behind retrieval augmented generation, but these responses look actually very plausible if you're not familiar with the relevant documentation at hand. And so, you know, they can cause a lot of headache, right? Because you might even run this code, which I do not recommend. I definitely don't recommend running any code from LLMs without reviewing it and really understanding what it does. But you might even run this code and, you know, get all these arcane error messages, and you'd be like, oh, what the heck? It's like, it's supposed to be, you know, this LLM is supposed to be all-knowing. I'd really like to, you know, just get good responses out of it without having to, you know, mess around with it, right? And so obviously, you know, we've got a completely hallucinated response here. And the code reviewer in this case, after the Python engineer just responds to terminate the group chat, because it says or it presumes that this is actually sufficient as an answer. Now let's actually look at what happens when we use RAG chat, right? Now RAG chat is going to look a little different. The boss assistant says that it tells the retrieval augmented user proxy agent pulling from SingleStore that you can actually retrieve knowledge and use that knowledge in your response. So here the boss assistant is calling the retrieval user proxy agent. It gives it the user's question, and then we pull up actually the context, the relevant context, which is going to be important for actually generating, valid FLAML code, right? We even get a little code snippet. We get, this is all still context that's been retrieved from SingleStore. We get, some additional information about, how, FLAML has integrated Spark. It has some additional information about how to actually use it in an example with Python data frames. And then so we're going to scroll down, and then we have the product manager responding after getting this this additional context. Interesting. So this is why benchmarking is important here, but interesting how the product manager responds here and not the Python engineer, right? But the product manager, obviously is still running with the same base model, and so it's also able to generate code, and it ends up giving, a code snippet which is actually valid for running parallel training in FLAML using Spark, right? And that's because it has all of this context, right? All of this context, which the boss assistant, prompted the retrieval user agent, the SingleStore retrieval user agent to actually pull from. Okay, wow, great. That was a lot. And then you see at the end here, the Python engineer terminates the conversation because it, deems that, this is sufficient for an answer for the user. Now we can get into some Q&A. Let's see, Akmal, do you want to maybe share with me like a theme of some of the questions that have come up so far?
Yeah, Alex, lots of questions about the agents themselves. Are they tools, for example? Sub agents. What can you talk to the internet using them? It's a whole bunch of stuff there. Do you have any thoughts on that, Alex? I mean, could you summarize that? Let's pretend you're ChatGPT. Could you summarize that in like one paragraph?
Okay, great. So tools is that's a really great concept that's come out in the last few months. OpenAI has come out with function calling, but the kind of limitation of tools is that you can really only expose so many tools to a single LLM before its performance really degrades, right? And so for those that aren't familiar, tools are essentially like actions that we make available to LLMs to, like, for example, browse the web, or run code, or generate an image. Like if you're using GPT-4 today, it already has access to tools, like all of those tools that I've just mentioned, actually. But when you extend past maybe like 3, 4, 5 tools, the LLM just really can't reliably pick which tool to use. And so that's where the kind of beauty and extensibility of agents really comes in. You can give each agent access to like maybe just 2 or 3 tools that it's really good at picking between, or maybe you even just think of each agent, at least in this example, of just having one tool, right? And then you have a hierarchy of agents, right, that ends up picking out sub problems to solve, that the agents can go out, and solve a well-defined sub problem. And then once you have that piece solved, you have, the pieces necessary to solve a higher level subproblem, and so on, right? And so in that sense, you can maybe even have, if you think of the boss agent as having access to the tools of everyone, below the boss agent, or not everyone, but every agent below the boss agent, then you could effectively have access to, an infinite number of tools. Obviously in practice, that's not feasible, but it gives you access to, obviously, definitely many more than like 4 or 5 tools before a single LLM's performance degrades.
Yeah, one quick observation, Alex. The Spark code you were showing a little bit earlier, absolutely. I've just been working with a bit of Spark recently. That code looks as though it would work. It's very, very accurate. I mean, I didn't have a chance to see it all in detail, but it looks pretty good. But it has to be tested, obviously. Make sure it does actually do what it says on the tin.
Yeah. I really can't emphasize that enough. Obviously, all these demos are really cool, but do not, just like you shouldn't run with scissors, don't go out running, LLM generated code on your, production environments without first testing.
Yeah. I think there's a couple of great questions there in the Q&A as well, Alex. I'm not sure if you're able to see that.
All right. So, let me pull up some of these questions. Okay, so from our Pitha, we have, are the tasks being routed to PMs, engineers, etc.? Are they agents? As the tasks are being routed, are the agents able to respond back with the right answers? Well, your mileage will vary. Obviously, in this demo, we're showing hopefully the golden path scenario, but benchmarking is going to be really important here, right? So you're going to want to make sure that you're setting up, these reliable indicators of performance, especially if you're using these multi-agent workflows in production, right? Before actually deploying them. I think it's actually especially important in multi-agent workflows because you do have, potentially more points of failure, right? You're going to want to make sure each agent is doing what they should, and then that the whole workflow as a whole is doing what it should, right? Maybe if it's a really fragile system, just one agent failing and hallucinating a response could potentially, that could cascade up to the top and give you a bad response up at the top. So important to benchmark and test here. Okay. So let's see. Why we need agents for this. So from Shravan, we have, why do we need agents for this when we could just do RAG plus one single LLM call? Actually, really good question. This hopefully, you can do essentially this entire workflow in just what Shravan mentioned, one single RAG call. So why do we bother with multi-agent workflows in the first place? And that's because this is extensible across an entire hierarchy of agents and sub-agents, right? So it's very possible that we want to work with, for example, multiple databases, and we want to work with, maybe even, we want to work with not just context from a SingleStore data store, right? But we also want to work with, web search information, and we want to be able to execute code, and we'd like to be able to also like listen to audio and watch have the LLM, like a multimodal LLM, watch a video, right? If you have a complex task like this, you're going to very quickly find out that delegating all to a single LLM is going to turn sour very, very quickly. And so the purpose behind this webinar is hopefully to give you the tools to extend to your production kind of or enterprise grade kind of problems and environments, right? Okay. So let's see. So Christoph asks, do all agents' prompt messages get updated after each turn, or does the boss decide which agent needs to know something? If all gets updated, doesn't that make it financially unsustainable? With n agents for one problem, you may be spending n amount instead of one. That's a really, really good question. I actually don't know the exact answer to that. I believe what happens today is you preset the prompt messages before running the whole group chat, and then you run the group chat, and the prompt messages stay fixed during the group chat itself. Because I think that, I mean, that does sound like a pretty computationally expensive problem of updating the prompts after each turn. So that's how I understand the AutoGen group chat to work today. Okay, great. So we have another question from Kulon, who asks, how are you thinking about front end for AutoGen to make it usable by business users who don't have technical knowledge? So really, really great question here. I'm actually going to share out, let's see, I'm going to share out a GitHub library for everybody. Rag. Now, I've only played around with this a little bit, but let's see. Oh, strange. Okay, I cannot find this example, but I will send it at the chat at the very end if we've got time. But you can use this library called Gradio, which is a really great open source library, which basically makes it super simple to hook up these LLM chat flows into a front end experience. So you can see, like, in a much more traditional chat interface, you know, the agents responding to each other in turn, in a hopefully more non-technical friendly interface. And that's something that you can, get up and running pretty quickly after you have everything running in code. Okay, let's see. Okay, so from Rebecca, we got, Alex, I loved your presentation. I wish there's more time for your descriptions. It's valuable walk through the code. However, I was expecting an actual demo. Would have been great to see how the agents work. No, really great point, Rebecca. Just for the sake of time and for this presentation, you can see we're already running up almost on the end of the webinar. We pre-baked some of these responses, or I ran the code before we actually did the webinar. So you're free to go and actually run the Python notebook yourself. We'll be sharing out all the code and all the relevant details after the presentation. But yes, just so that we can get to as many questions as possible and hopefully clarify as many questions as possible. Great. Okay, we're running up on time here. I'm going to go a little further back. So from Sarah Wilson, we got, how do you go about defining your agent hierarchy? Do you explicitly state it in your agent instructions, or is it defined in some other way? So really great question. So you actually do end up defining this in code. I'll see if I can actually point out where this is defined. See. So I'm going to try my best to explain this code, though I know I have some just personal opinions on how AutoGen's, their SDK could be improved a little bit. Essentially, what we do is for the boss, when we retrieve content, we're actually going to like the boss is actually going to give what AutoGen defines as a problem or a problem statement to the boss aid. And then when the boss aid gets that problem statement, then it goes out into the context store and actually retrieves the information. And then after that, so that's the kind of boss aid kind of line of communication. We also have we also have a line of communication between the PM, the coder, and the reviewer. And so they basically kind of see each other as functions. So going back to like tools, like the PMs, coders, and reviewers can call each other as tools to, the PM can make a problem specification and then ask the coder to code it up. The coder can ask the reviewer to review its code, right? They all kind of see each other in their kind of prompt as tools that they can actually call each other up for. And then finally, the boss is the one that's in communication with the PM. So the boss gives, the problem and the context, to the PM, and the PM is the one that actually draws up the problem statement. In this case, in the example, we actually saw that the PM just went straight ahead and coded up the solution. But in the kind of ideal scenario, we would have seen that the PM actually ends up calling the coder as we've intended it to, and then the coder calls the reviewer. But as probably many of you have seen already, LLMs are inherently non-deterministic systems, and so what's really important, as I probably sound like a broken record at this point, but what's really, really important is benchmarking your outputs and making sure that your outputs are up to a certain amount of improvement over the baseline, and ensuring that that's repeatable. Great. I think we're running up on time here.
Yeah, I think we should probably go ahead with the Apple AirPods winner announcement.
Let's do that. That's more exciting.
Before I announce that name, just quick reminder, Monday we're going to be doing that Google Gemma webinar. Come check it out. We got a really fun demo and code share planned. That's that Google Gemma, the new lightweight model, open access model. It's really cool. Come check it out on Monday. I just put the registration link in the chat, and I hope to see you there. Now, the announcement you've been waiting for, today's AirPods goes to Sam Swaminathan, the Senior Manager of Engineering at US Bank. Congrats, Sam. Thank you for joining. If that's not you, don't give up. We're going to give out one more AirPods by the end of the day to someone who has tried out Alex's demo here. We're going to send out the link for this notebook and the video recording of this session. So give it a chance, and hopefully you'll be the next AirPods winner. Thank you so much, Alex, for an awesome presentation today. Thank you to our audience for joining us. Enjoy the rest of your day and your weekend. Thanks, everyone. Bye-bye.
Thanks, everyone.